So there's an additional type of problem that I want to talk about that's similar to what we did in the homework on 7 and 8. So here we're asked to construct a sinusoid with an amplitude of 4, a period of 3 pi, and that passes through the point 3, 1. So this is basically the same problem that we did for 7 and 8. The difference here being, instead of giving you all the possible information you wanted by looking at the graph, we've pared it down and given you kind of a minimal amount of information to kind of work from this. But that's okay, because we can still do a problem like this. So let's take first and look at that the amplitude is 4. That tells me that the absolute value of A is 4. So either A is 4 or it's negative 4. The period equals 3 pi tells me that 3 pi is equal to 2 pi times the absolute value of C. Or really that the absolute value of C is 3 over 2. Or that C is equal to 3 over 2 or negative 3 over 2. Everybody so far so good? Now the last piece of information, the fact that we want the function to pass through this point, this somehow has to tell us the values for h and for k, as well as giving us some idea of whether these a's and c's should be positive or negative. Everybody okay with that plan? Okay. So, in this sort of situation, there's two ways to approach this. You can do it the hard way or you can do it the easy way. Let's do it the easy way. So, if we have the choice, we're told nothing about this 0.31 other than our graph has to pass through it, right? We're not told that it has to be a maximum or a minimum or a midline point. Just the graph has to pass through it. So the easiest situation for me to do is to pick that to be a midline point. If I assume that's a midline point, I can use the sine function, and in that case, then my value for h is just going to be 3, and my value for k is going to be 1. That's the best case scenario. Let's explain why immediately by choosing that to be a midline point and choosing the sine function, how I get that as h and k immediately. Because that's probably not entirely clear why that has to be the case. Everybody okay with this so far? So let's just kind of explain this a little bit further. But that's the shortcut. All what I'm doing now is just explaining why this works. So I know that we have this transformation map that I can use to connect the parent function to any transformed version of that function. So for sine, I can take the midline point 0, 0 and map it to some other midline point. In this case, it's 3, 1. So if I apply this transformation map, that tells me that c times 0 plus h and a times 0 plus k should give me that 0.31. Well, c times 0 plus k is just k. A times 0 plus k is just k. I said that wrong. So I get that HK is 3, 1 and H is 3 inverse 1. Everybody okay with that? Now if I've chosen, this is the even better part, if I've chosen that point 3, 1 to be a midline point on sine, is it going to matter whether the A's and C's are positive or negative? Do the A's and C's affect the period or amplitude? Or the sign of A and C affect the period or amplitude? No. If my point is on the midline, if I do a reflection, is that going to change that point being on the midline? No. So it doesn't matter. I can pick them to be whatever I want. I don't know about you, but I'm not in the habit of making my life more difficult than it needs to be, so I'm just going to pick positives here. So when I plug everything in, I get this. You can check this by looking at the graph on the calculator and making sure that it matches the attributes that we're looking for. So graph, zoom trig. So I can check the period if I want. It's not easy to do it with this window. Maybe I'll make this window a little bit bigger. Maybe I'll make it 4 pi instead of 2 pi. And because the amplitude is so big, maybe I'll make this -6 and +6 to make sure I can see the whole thing. If I were to count from like minimum to minimum or maximum to maximum, I'd see that the period is 3 pi. If I count the distance from minimum to maximum vertically and divide that distance by 2, I'd see that period is 4. But here's the more important point. I want to make sure that this graph passes through the point 3, 1, correct? So what I want to do is I'm going to press second and trace, and then select the value command, and pick the x-coordinate of 3. So what that function does is it finds the point with that x-coordinate on your curve. So I can see that the point 3, 1 is on that curve. So I'm positive that the function that I've written is acceptable, that it meets all the criteria we're given. Everybody okay with that? So again, the calculator stuff I did at the end was just kind of a check there. Let's do another example that's a little bit more complicated. Got a little bit more going on. So let's say we want to construct a sinusoid that has a minimum at 510, and the next maximum is at 532. Here we're given considerably less information, right? What I'm going to do is I'm going to start by just kind of drawing myself a picture. So let's say here's like 510, and here, say, is like 1532. So that's basically what we're given here. Something is like that part of the graph. Everybody happy with that? Okay. Well, easy still to find k, because k is just y max plus y min divided by 2. So that's going to be 21. And the absolute value of A is still easy to find. That's y max minus y min over 2. So that's 11. And the period isn't too bad. So how much of the period have I got between this minimum and that maximum? Looks like half of it to me, right? If I were to go min to min, that would be one period. So min to max has to be like half the period. Do you guys agree with that? So in our case, half the period is going to be 15 minus 5, or 10. And now I know that the period is equal to 2 pi absolute value of c. To figure out the full period. So the full period is 2 times half the period. And so I get that the absolute value of c is 10 over pi. So now all we need to do is determine the signs on A and H. A and C, figure out the value for H, and pick the function that we want to use. The first thing I'm going to do is pick the trig function I want to use. In this case, should I pick sine or cosine? There is an easy choice and then there's a hard choice. That's the hard choice. And the reason I want to pick cosine is because I know about mins and maxes. So whenever I know about mins and maxes, cosine is usually going to be the better choice. Just like our rule for picking cosine before depended on where the maximum was on the graph, where the maximum, if the maximum was crossing the x-axis, or I'm sorry, y-axis. When we looked at the graphs, told us cosine. If we're talking about maximums here, we're going to use cosine here as well. Okay? So when you think maxes and mins, think cosine. When you think midlines, think sine. Okay. So I have two choices here. I know the maximum for cosine happens at the point 0, 1. That's what I'm just getting from my parent function. I can then map that to either the maximum for my transformed function, which is at 1532, or I could take the maximum from cosine and map that to the minimum of my transformed function, which is at 510. If I'm going maximum to maximum, would a reflection be occurring? No, right? If my maximum becomes a minimum, would the reflection have occurred? Yes. So the only thing I have to adjust is the value of A, depending on the situation. Does that feel okay there? So to find H, I know what I'm going to do is I'm going to do C times 0 plus H, A times Y plus K should equal 1532. So really what that tells me is that H is 15. Similarly over here, tell me that H is 5. So if I put things all together then, I have y equals 11 times cosine of the reciprocal of c, x minus h plus k, or y equals negative 11 cosine reciprocal of c, x minus 5 plus k. Either of those would be fine, ways to write the cosine. So notice what this process here boiled down to. If I went max to max, my a is positive and the h is the x-coordinate. If I chose to go max to min, the a is negative and the h is the x-coordinate. So don't feel like you need to write all the process out. I'm writing all the process out so it's not magic, so that justify to you like why we're able to figure out that value for h, why all of a sudden it is the x-coordinate here, and why things are negative and positive. But if you want to just kind of simplify this down for yourself, max to max, a is positive, and then your h is the x-coordinate. Max to min, a is negative, the h is still the x-coordinate. For the minimum this time, like the h is the x-coordinate of the respective point you're mapping to. But of course. Does that feel okay? We'll do some more practice in class with this stuff on, on Monday, I think is the next time we meet, right? We'll give you guys just some handouts to work on in class and let you guys get some more practice on this. As I know it's not, these are not easy skills because there's a lot going on here. There's a lot of formulas that when you've seen it for the first time, you just don't quite remember, and it's hard to keep pace with some of the stuff I'm doing in the examples. Because you're struggling to remember the formulas and remember all these relationships, and that's okay. It just means you need some time and practice to kind of grind through some stuff to where you get used to what these formulas are, so you're not like really having to break your thought process going back and figuring out, like going down all these little rabbit holes to kind of fill in how to do these little sub-skills. So that being said, let's start talking about some graphing now. So the main tool that we're going to be using to do this graphing is this transformation map. So we presented this in Chapter 1. Probably a lot of us overlooked the importance of this, but this is going to be a primary tool for us to use when we do all of the graphing here involving these trig functions. It's going to make our lives much, much easier having access to this and using this effectively. So this is something that you definitely want to have memorized. So the idea here is if I take a point from my parent function, I can transform it to some other point in my transform function by taking the x and y coordinates from the parent function, multiplying by c and adding h, and then multiplying by a and adding k. So the question is, what are these key points here that I'm going to be using to do this? Well, for sine, the key points I'm going to use are the values of sine at 0 degrees, at 90 degrees, at 180 degrees, 270 degrees, and then again at 360 degrees. But when we're graphing these things, instead of using degrees, we typically use radians. So at 0 degrees, sine is 0. At 90 degrees, sine is 1. At 180 degrees, sine is 0. At 270 degrees, sine is negative 1. And at 360 degrees, sine is 0 again. Cosine, at 0 degrees, cosine is 1. At 90 degrees, cosine is 0. At pi degrees, cosine is negative 1. At 270 degrees, cosine is 0. And at 360 degrees, cosine is 1. Do you need to memorize these key points? Not really. Do you know why not? They're all in the unit circle, right? These are just the quadrantal angle values on the unit circle. We know what cosine of 90 degrees is, or cosine of pi degrees, or pi radians is, or whatever. We can just look those values up on the unit circle if we don't remember them. Now, I'll tell you this. You'll probably use these often enough that you're going to end up memorizing them on accident. You know, just because you've used them so many times, and you get sick of looking them up. You'll probably just end up remembering them. But if you're never not sure, you can look it up off the unit circle, right? So let's take the example here. Say that we wanted to graph y equals 2 times sine of negative x plus pi. The first thing I do is I'm going to rewrite this so that it's obvious to me what my values for a, c, h, and k are. Oops. Minus a negative. Oh no, that was right. Great googly moogly, Mr. Kulak. That's better. Okay. Everybody happy with what I've done there? Nothing sneaky. Just figured out my A, H, and K. You don't even have to write the intermediate version that I wrote down there. I just wrote it down so that it was clear where I got the values for A, H, and K from. All right. So what I'll do now is I'm going to write my transformation map. So in our case, C is negative 1, H is pi, A is 2, K is 0. So I've just filled in the specific values for this function for my A, C, H, and K. And now, because we're doing a sine function, I'm just going to copy down my key points for sine. And I'm just going to perform my transformation. So when I plug 0 in for x, negative 0 plus pi is just pi. When I plug 0 in for 2y, I get 0. When I plug pi over 2 in for, I have negative pi over 2 plus pi, which is just pi over 2. When I plug 1 in, I get 2. When I plug pi in, I get 0. And when I plug 0 in, I get 0. When I plug 3 pi over 2 in, negative 3 pi over 2 plus pi is negative pi over 2. And when I plug negative 1 in, I get negative 2. When I plug in 2 pi, negative 2 pi plus pi is negative pi. And when I plug 0 in, I get 0. 10. Yep. Yeah, so I'm just taking like my x, plugging it into the x, and then taking my y and plugging it into the y. So, nothing sneaky, right? Now I have everything I need to generate as much of this graph as I want. Let's see. Pi over 2, pi, negative pi over 2, negative pi, 1, 2, 1, 2. So, if I graph this, let's see, I have pi, 0, pi over 2, 2, 0, 0, negative pi over 2, negative 2, negative pi, 0. So when I draw my graph, it's going to look like this. But what if the instructions had asked me to graph this instead from just what if it wanted me to graph from negative 2 pi to positive 2 pi? I'm going to need 4 more points here, right? To fill out the space that it's asking me for. Am I going to generate those with my map? No. I'm just going to use the pattern that's going on here. So after this point here should be a maximum. And then after the maximum, I should be back on the midline. So after this point here should be a minimum. And then after the minimum, should be back on the midline. So I can just keep following my pattern and generate as much of this graph as I want in either direction. I'm not going to write down any additional work for that, because once I have one period's worth of data, I can generate as much graph as I want. I just keep repeating what I had done, modifying appropriately. Does that feel okay, guys? So, for next time, what I'd like you guys to do is 9 to 14. So that's 6 problems, I think. Should be doable.